Hello, everyone, and welcome back to the Eureka channel, your go to hub for mobile application development made simple. So, in 10 minutes, I'll show you how a POS application communicates with a backend server. If you have ever used a POS device in the shop, or you're trying to build a fintech app in Kotlin, say an app that helps you make payments for value added services like airtime purchase, uh, data purchase, and so on. You've probably wondered what's actually happening behind the scene when a payment is processed. So, in this tutorial, I'll break it down step by step from sending requests, encrypting sensitive data, handling API responses, basically everything that you need to know. So stick around to the end because you walk away with a clear understanding of how POS app actually talk to servers in real time. So let's start with a real world scenario. Imagine you are in a supermarket, you swipe in your card on a POS machine, or you are on your phone trying to make a payment. And just within seconds, you either get an approved message or decline. Now, here is what happened. The POS app on the device collected your card details. It encrypted those data for security and sent the data to the backend server. The backend server then talked to the payment processor or your bank, and then the response came back all in no time. So the magic here is actually backend communications. So before I show you in the codes, let me break it a little bit further down. So it all starts with a request. Your POS, which can also be known as the client, builds a JSON payload with information like the transaction amount, the card details, timestamps, etc., and then encrypted those details for security. Most of the time, the encrypted technology used is RSA, 3DS, which is also known as triple DES. And then your POS makes an HTTP request to the backend, and then the backend replies with a JSON response, either with a success or failure message, and then this message gets displayed on the client, which in this case is the terminal or the POS. So here in my codes, I'm going to be showing you a project I have done by myself, and it's already live, and I'm just going to be making an example from the airtime purchase. So let's say for example I want to buy airtime on my phone. I just click on the airtime section of the app, and I so you can do a drop down to see all the networks that are available. So I'll just select MTN and then put in my number. Let me just say 1, 2, 3, 4, 5, 6, 7, 8, right? And then I put in an amount, and then I put in the pin. So I'm going to be putting in the wrong pin so that I don't want a successful transaction because the project is actually already live. So I'm going to fire that and just I want to show something. So pay attention to the two. So you already see that there's a response and it said invalid pin, and that is what is getting printed in my log at. You can see the success message as false and the message is invalid pin. So this is the endpoint I called. That is the endpoint, and this is my. Let me try to expand this before I now explain what is going on. So this is my request. This is my request body. This is the request body I just sent. You can see this is the phone number I entered, this is the amount, and this is the pin. And this is the network, this is the service code. These are just extra parameters from the backend. And you see something like encrypted payload. So this was the JSON body that I built, but before sending it, I had to encrypt it for security reasons. So only backend can understand what this encrypted data means. So that is the data I am sending here and makes me to get this response. So that said, let's go into the code and try to understand what is going on. All right, so it all started here in my repository class. So this is my payment repo, and you can see all the methods that call all the actions. This is for payments, airtime purchase, this is for data, this is for disco, and this for TV. So, so it all started here, and the payment repo makes a call to the API layer. But as you can see, this is an interface class, so the method has to be called somewhere else, and that is happening here in my implementation folder. You can see I have segmented everything into folders in a very neat manner. So I'm actually following the MVVM architecture. If you follow my last video, you understand everything I'm talking about. So 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 the method exists here in the implementation folder, and here in the payment repo implementation, you can see that the repo is making a call to the API, and it is sending the airtime request. So if I seed into this airtime request, you will see the data that I showed you in the local the other time. So I have built all the all the payload, all the request payload, and I have encrypted them and put them in a data string. And that is what you are seeing there. So I go back to my payment repo class. So it make a request to this API layer. If I seed into this API layer, you will see now. So what I'm using here is a retrofit. So I'm using retrofit make network communication to backend very simple. So because it is a post request, I have annotated it with a post annotation, and that is the URL. That is the URL, and you see that it makes the request with the airtime request class and waits for the response with the airtime response class. If I see it into the airtime response, this is the JSON response that backend sends back. So I go back to my API service. So this is the URL link. This is the URL link that was provided by the backend, and the the base URL lives here because I am using a Hilt implementation. So that's why I'm having an app module class here, and this is the base URL. So you can already see that in the response I go back from my log cart. All right. So when that is done, I said something about data encryption because in this payload now there is a pin, and I don't want my pin exposed so that fraudulent activities are not carried out on my account. So we had to encrypt the pin, majorly for the pin. Every other data are not really sensitive, but the pin is a sensitive matter. So if I come to where I am doing the encryption is in this same payment repository class. If you look down, you will see a method that is called encrypt payload, and the uh, encryption method I used is actually the RSA as agreed by the backend developer, because this actually must match the same encryption method that the backend use. or else you are going to have errors. And how that works is the backend already provides me with a public key. So it is that public key I use to encrypt all the data. It is the public key that I use to encrypt all the data. So the encryption method here is actually very simple, as you can see here. So when that is done, then we can now move to the view model class. Don't forget, in my last video when I was teaching about MVVM, I'll put the link in this video. When I was teaching about MVVM, I already told you that view model is the class that is the layer that sits in between your model class that interacts with the backend and your view that interacts with the user. So in the airtime purchase view model, you see that that is where um, uh, I'm exposing the results to the view class. That is where I'm exposing the results. So I've already said here that when the airtime purchase class with the encrypted payload has been done, and then expose the result dot body dot message, like the message inside the response that is coming back from the backend, and check if it is time purchase successful. And then if that is not true, come back to the else block and pick the error message. So that is what I'm exposing here. That is what I'm exposing to my view class. And in my view class, I'm using a fragment, time fragments. Remember in that MVVM video, what I used was an activity, because I said your view can render uh, views by either a fragment or an activity. So what I used here is an activity, and you will see where I'm observing what is coming from the backend. All right, so if I go down a little bit, you see where I'm building the JSON request, and you can see all of that. This is my pin, this is my amount, this is the phone number, this is the selected network, service code, and vendor type. So, and then I'm making and sending the request here. So, view model I've already extracted. So, I've already extracted the method to be called in the view model, and then I pass in the airtime request as an encrypted data, as an encrypted data. So that is how that works. So that's it. We've just simulated how POS app talks to a backend. So to just cap it all, your POS app builds the request, encrypts the data, send the request, receive response, and display the results. So of course in production there are more layers like ISO 8583 protocols, pin block, encryption, and terminal queues. But this tutorial gives you a solid foundation. So if you found this helpful, smash the like button, subscribe for more Kotlin and POS tutorials, and drop a comment telling me what topic you like next. Maybe how POS app handles ISO 8583 messages, or building a secure PIN pad in Kotlin. Thank you for watching, and I'll see you guys in the next one.